Hey everyone, this is Dr. Walker. Let's do an example from video 501, vector addition using unit vectors. In this example, we want to add two vectors A and B. Note that these are two-dimensional vectors, but a method can easily be expanded to three-dimensional vectors as we saw in video 501. Remember that to add vectors, we are going to add all of the components separately. So we can write down what the components are. Whatever's in front of I hat is the x component, so ax here and bx here, and whatever is in front of j is the y component. So we have ay in front of j here and by in front of j. So to add the two vectors together, what we're going to do to get that resultant vector is we're going to do ax plus bx, and that's going to be followed by I hat, and then we're going to have ay plus by followed by j hat. If these were three-dimensional vectors, they had that z component, that k hat, then we would add az plus bz and follow it by k hat. In this example, both az and bz are 0, so this whole thing cancels out to 0. Alright, so we're going to have 2 plus 2 I hat plus 2 plus a negative 4 j hat. So we're going to have 4 I hat minus 2 j hat. And we have found the sum of these two vectors. This is the resultant. It has a magnitude and a direction. Now, the magnitude and direction may not be clear from this notation, and we can find the magnitude and direction separately if we want to. But this is a completely acceptable answer as long as a problem doesn't specifically ask for the magnitude and direction. If it does ask for the magnitude and direction, then all we're going to do is use the Pythagorean theorem to find the magnitude, so the rx squared, so the 4 squared, and the ry squared. And that will give us about 4.5 for the magnitude of this vector. And if we wanted to find the direction of the vector theta, we would do the inverse tan of the y over the x. The ry, I like to use a positive number 2, and then the rx 4. And the calculator will give us approximately 27 degrees. But we know that that's not the final answer, because if we visualize the vector, it has a positive x component and a negative y component, so it's going along this direction. So the 27 degrees is going to be clockwise from the positive x-axis, but usually we like to specify the counterclockwise angle, so I'll call that phi. So phi is actually going to be 360 minus 27, or 333 degrees would be the direction of this vector. So hopefully you can see how easy it is to work with unit vectors and how it helps vector addition. And if you had a z component to either of these vectors, then you would just add them here and you'd follow it up by a k hat to specify that z direction.